counted to the third, not the fourth. So you start with the 3 over 3, then you add a 3, came to 6, then you add a 3, came to 9, then you add a 3, came to 18. Right? So if you come here, you're going to stop directly before the 18. So you'll be in quadrant 4. And 3 goes into 180 how many times? 60. So this is a 60-degree triangle. So if you wanted to label these, if you had to, you didn't have to on this one. You just had to find me this reference angle, and I wanted it in radians. Just go over it. And again, if you're 17 pi over 3, and this is 18 pi over 3, just subtract it. God bless you. There's your pi over 3. Or 60 degrees, whichever you wanted to do. But this is what you would do then if you're going to find all the trig functions for it. Set it up. This is your reference angle. Remember, all your reference angles make a bow tie. They all come to the x-axis. So these are your little reference angles in here. All these triangles are equivalent. They're congruent triangles that we just reflected all the way around this axis. We put these on your XY axis, and that helps you find your positives and negatives as well. If you just put it into place, like where is my X positive, where is my Y positive. You could do, all students take calculus, you can do that too. I like to use the X and the Y axis, mostly because in the next unit we're going to be graphing them anyway, so it's good to start thinking in terms of X and Y.
What was the answer to that?
Pi over 3. You just have to find a reference angle. So if you came all the way around here, Lily, you came to here, this is short of 18. You came around a couple of times, and you came back to here, just short of 18. It was 17. So if you just took 17 from 18, it's just 1 pi over 3 in this case. Okay, if I give you radians, give me back radians. If I give you degrees, give me back degrees. What does this mean? No help. If I say evaluate sine of 30 degrees, wouldn't it be 1 over 2? That's all I want. What am I asking for? Just the sine. Just the sine. This one? So did you get a 60-degree angle?
Yeah.
So 60 is the same as pi over 3. 60 goes into 180. 3 times pi over 3. It's actually just one short. If you came all the way around, this would be 18 pi. Like all your units are pi over 3, pi over 3, pi over 3. By the time you come here, this is 17 pi over 3. How many more pi over 3s to get to 18 pi over 3? 1. So that's this little angle right there. Pi over 3. So if I say this, all I want is the sine of 30. So all you have to do is draw me a triangle and say this is the 30 degrees. This is the one I know. So I say sine opposite over hypotenuse. That's all I want when I say evaluate that. What if I say evaluate this? I just want the cosecant of 120. How would you do that? You have to find your reference angle. What quadrant are you in? 2. What's my reference angle? So then, how would you find your cosecant? Okay, you would label your triangle. X is negative, Y is positive, R is always positive. What would be my cosecant? 2 over radical 3. If this bothers you, do the sign. Well, positive in, the Y is positive in quadrant 2. Bring this out here, use this. So what if I said this? 2 over radical 3? 2. The sine would be radical 3 over 2, so the cosecant would be 2 over radical 3. But if I said evaluate this? Same thing. Isn't it the same thing? Is R and I the same angle? Yeah, where is 2 pi over 3? This would be 3 pi over 3.
Yeah, and then your one before.
This would be 6 pi over 3. And your 1 before it. So Lily, if this is 2 pi over 3 and this is 3 pi over 3, what's my reference angle? 1 pi over 3. 60 degrees, right? And there's my triangle.
So we'll do 60 or what?
No, what am I asking you to find? Evaluate the cosecant. So what does your answer have to be? 2 over radical 3. Isn't it the same as this one?
Find it so that it's degrees.
When do you find an angle in degrees? When I say this. Okay, let's say evaluate. I'm going to use the word evaluate. What do I do for this one? What am I looking for? An angle. Why would you say an angle? Because what's the unknown here? Theta. Theta is my unknown. Okay. And so, where would I look for this?
So does that say n cos is negative?
And the cosine's negative. Quadrant 3. Okay, Allie says quadrant 3, why? They're both negative. I want my y to be negative. I want my x to be negative. Okay, my y is negative down here. My x is negative here. So I've got to be in quadrant 3. That's why I had to add this. Because if I left you as the sign of negative 1/2, you could be in either 3 or 4. If I say find 2 angles that have a sign of negative 1/2, I'm looking for 3 and 4. If I narrow it down to this, so then what do? I still need to find my angle. So then what do? I label. So sine is what parts? Y over radius, yep, y over r. So I'm looking for y over r. So I come here, I get my r. What's my reference angle? 45. How many times does 45 go into 180? 4. So it's going to be something pi over 4, right? So I'm going to say 4 pi over 4, 8 pi over 4. If I come all the way around, what would my angle be? 5 pi over 4. So this answer is 5 pi over 4. That was a lot to get that one. That one I'm looking for an angle. What told me I'm looking for an angle is this guy right here. This is my unknown. When I write evaluate the cosine, the sine of something, and I didn't have this out here, then just put this is equal to x. What am I looking for? I'm looking for some kind of trig ratio. When I'm missing my angle, I'm looking for an angle. So when you're looking for an angle, you're going to go to your quadrants, you're going to set up your triangle, and you're going to figure out your reference angle, and then you're going to figure out what's that terminal side, what's that angle. I think that's what's confusing you guys.
So if you gave us that one, you'd want the angle and the theta, or radians?
And all I want is, where did I put my answer? Right there. That's my answer. 5 pi over 4. Most of the time you'll answer in radians. Unless I specifically say degrees and radians. There might be one that says degrees and radians, just so that you get used to seeing both. Yes.
So both of them we have to use opposite over opposite.
You're still using your special triangles and your trigs.
Sine of 30 are given the angle, and then for the other one, you simplify.
Yep, yep. Yep. Now, you could always pick up your calculator. You could pick up your calculator. If I do this, and here's the problem with your calculator. If I do this in my calculator, I take the sine of this angle. It's going to give me this angle that falls here, because that's my first negative sign. There's another one over here. It's not going to give you that. Those are called restricted domains, and we're going to be getting to that soon. But you can't really depend on your calculator to give you these, because every sine, every cosine, every tangent has a positive, two positives, two negatives of those functions. So you're going to get two different angles, and your calculator can only give you one. Your calculator restricts a domain, which I'm sure you didn't get to that, but we will get to that. So I think that's what you guys are having a little trouble with, deciding what it is, how we want to answer this. Okay. So let's move along and see where we are. And you're not the only ones. It's always hard to figure out what is it that we want. Do we want an angle? Do we want a trig ratio? You're very rarely going to pick up that calculator. Very rarely, unless you're doing like a Pythagorean theorem or something, and you have to like put it in your calc. Basically, you're not going to be using your calculator. So find the exact values. Was everybody okay with these?
Yeah, I just forgot to simplify the radicals.
Simplify your radicals. These weren't able to simplify.
Your points off if you don't do that.
If you don't simplify or reduce your fractions, yes.
Wait, how did
These weren't simplifiable.
Yeah, these were circles.
Radical 61.
Yeah. I did radical 244. Because you had to simplify that 244 to 2 radical 61.
So 2 radical 61.
And then divide for 2.
Okay, so here. What did it come out to be? Radical 244?
Yeah.
All right, just pick up your calculator. Divide it by 2, divide it by 3, divide it by 4. See what it can be reduced by. So, okay, you can also do this. This works for squares. This works for, you'd have to go pretty far up here, but you can. All right, so if you're doing, if you're doing squares or cubes, set this up and then square these guys. Go all the way up. If you're doing a cube, you can do the same thing with a cube. I'm not real good getting up here. 225. I think that's 225. 14 is 196. Thank you. Okay, so now, here's the easiest way if you're stuck rationalizing. Where does 244 fall? Right here, doesn't it? Falls right after the 225. That's where my 244 falls. If you want to find the highest number you can divide into this, you just start going down. Can I divide 15 into that? Obviously not, because it doesn't end in a 5 or a 0. Can I divide 14 into that? So I try. 13? Probably not. I keep dividing all the way down, and the only thing I could divide into that is a 4. 4 times whatever that comes out to be, 61, and then take the square root of 4, and there's your 2. Yes.
You had 2 radical 61, but then you don't use that
I reduced them. Right here, I reduced it to here. I reduced them all. Remember I said it's easier to reduce it once rather than each one. So each one was divisible by 2. So just reduce it here. That's why I love to use a reference box, because that's all I need to focus on after I get my pieces. So once I get my pieces, then I do my rest of my stuff. And these are all going to be positive. This might take a little longer. I mean, 244, I would just sit there, divide it by 2, divide it by 3, divide it by 4. You would find it. And once you divide by 4 and see the other one is 61, that can't be reduced. So you know that would be it. But this works real good for triples, because everybody gets confused with the cubes. Do this with the cubing, and it's so much easier.
So if we didn't simplify everything,
you're going to lose points. Yep. Remember what I said in pre-calc? We don't tell you that in your directions, but everything is simplified. Everything is left in reduced fractions, reduced radicals, reduce everything. Trig functions are always left in exact values, radical forms, fractions and radicals.
But you wouldn't simplify something if you had it in radians, like if that was your answer.
Your angle is radians, not your trig functions.
I know, but I just,
You still would, if you have 2 pi over 4, what is that reduced to? Pi over 2. You would still simplify that. Yes.
What if the cosine be 3? What if it be 2 or 3?
Cosine? 2.
Yeah, do you have to?
Can you divide something into 4 and divide it into 3? Don't take the square root. Can you divide something into 4 and divide it into 3? No. Not the square root.
4 over 8.
4 over 8, yes. Absolutely. And you can put those in your calculator to see if they're reducible. Let's see if I can scroll this down at all. Okay, again, this happened again. So we did one of these. I can't remember which one.
you started.
Did we do 6? Set it up?
I don't think we did 6 or 7. You said that we had those.
Oh yes, that's right. We just got done doing those. Was everybody okay? Find the coordinate, figure out what quadrant you're in, label your triangle, and find your missing side. Again, I reduced them here. Rather than wait and reduce each one. That was your 3, 4, 5 triangle. You know your 3, 4, 5 and all your multiples of that. And then I reduced these as well by 2. Because once you set up a fraction, you're going to have to reduce it anyway. So reduce your x, y, and your r right off the bat. Just keep track of what's positive, what's negative. And then go through it at the end and make sure that you did put your positives and negatives. Because sometimes after you get this all done, you forget to go back and look at the positives and negatives. If you like to put the negatives on here, this is fine. I usually don't. I usually put the negatives in my reference thing. Because I probably never write big enough to fit my negatives in my diagrams. Can everybody do this?
I just put it in the simplify.
Simplify. Gotta simplify. Gotta simplify. Alright. So here's where I'm looking for an angle. Right? My unknown is my theta. That's an angle. So I'm looking for some kind of an angle. So I want this angle to have a secant of 6 over 5. I'm not looking for an angle, sorry. I should have read the directions. Find the 5 remaining functions. Okay, so I need to locate where does this angle reside. So I say, okay, secant is the reciprocal of my cosine. Cosine is my x, and x is positive here and here. So I could have 2 possible places. Now I narrow it down. This is to help me figure out what quadrant do I want. I can't just give you this, because you have 2 quadrants for that. So I look and I say, I also want tangent to be negative. Out of these 2, everybody's positive in 1. So tangent has to be negative here. So my angle is going to reside in quadrant 4. I drop my triangle, I label my sides, I figure out what's missing. Here's my 5, here's my 6, and here's my 5. I do Pythagorean's theorem, and I find out this is radical 11. And in quadrant 4, my y is negative. Everything's reduced, everything is simplified right here, and I build my 5 functions. Good. I do the same thing over here. I say, where is cosine negative? Cosine is negative in wherever my x is negative, in 2 and 3. So which one do I need? I want the one where sine is also positive, and that would be right here in 2. 2 and 1, so they overlap in 2. So my angle resides in quadrant 2. I drop my triangle, I label my X over my R, I find my missing part, I set it all up, and find all my pieces. This is a typical one you're going to see. Isn't it easier without rationalizing the denominator, then you can just flip that thing over and you're done. Questions on these at all? No? Just be careful of your positives and negatives. Do I care where my negative sign falls? If it falls here or here by the 5, even though my 2 is negative, is it okay I put it by the 5? Absolutely. Remember, I can do this, I can do this, or I can do this. It's one negative. It doesn't mean that this guy had to be negative. I just had you put this in your calc so that you get used to seeing like how to put radians, how to put degrees in. I want the tangent of this angle. So we don't have a special angle for this. If I tried to draw a triangle and I said 33 degrees, I have no special angle for that. I can't give you exact values. So I pick up my calculator and I give you my tangent. 3 decimals is fine. Rule of thumb, 3 decimals. This guy, I'm still asking for a secant of an angle. Now you have a couple of ways you can do this. You can just put your calculator mode to radians and put that in. 1 over cosine, 1 over cosine, and say 12 pi over 5. Use your radians. Or you can flip that to degrees and leave it in degrees.
Is that how you have to do all the reciprocals but
1 over. I think the tangent one doesn't work. I'm pretty sure the tangent one doesn't work. Like if you were looking for a cotangent, I don't think the tangent works because the tangent, I don't remember if the tangent works or not.
We have to, for 8 to be, for 5 to be 180, we have to change it to degrees.
If you want to put it in degrees, you want to put your mode in radians.
I thought you said that we have to put it in radians.
If you have a pi, then your mode has to be radians.
So we put 12
Over 5. You put it just like that is, as long as your mode says radians. If not, use your formula. When you want to get rid of the pi, you multiply it on the bottom. Out comes this. You can multiply this times this, divide by that. You can divide this into that, and you get a degree. Okay, so now the next one, I asked you, yes. Oh, no, that's your angle. Just put your angle there. Yeah, that's where your angle would be. Wherever it gives you the place to put your angle. Okay, this one, I asked you to find 2 angles. 2 angles because every cosine has 2 positives, 2 negatives. Because of the way your quadrants work. Every secant has 2 positives, 2 negatives. So I said, okay, cosine, start like this. I'm looking for an angle. I want your angle. I want where cosine is negative. So that's my x value. My x is negative here. So quadrants 2 and 3. So I drop 2 triangles. I'm going to have to get 2 angles. One that's going to start here and terminate here. One that's going to start here and terminate here. Remember, when we draw those triangles, those are the terminal sides, the radius. So I say, okay, let me build my triangle, and if I didn't flip it over, I'd still get my x. My x, let me put it here. My x would be radical 2 over 2. If I do Pythagorean theorem, this is also going to come out to be radical 2, which tells me, oops, I have a 45-degree angle. So 45 goes into 180 4 times, so it's going to be something over 4. So 4 pi over 4, 8 pi over 4. This gives me 3 pi over 4. This gives me 5 pi over 4. 45, go like this. This is 180. I'm 45 degrees short of 180. So 180 minus 45 gives me 135. I'm 45 degrees past 180. So 180 plus 45 gives me 225. And check it in your calculator after you get all this. Put in cosine of 135. You'll just have to put this in and it'll come out to say negative 0.707. That's what this radical comes out to be. You put in this second one, cosine of 225. That'll also come out the same.
Why'd you put the radical to look up radius?
Where are you? I don't
Did
know.
you put the, wait, did you label the radical to on the hypotenuse?
On the hypotenuse. I unrationalized this, but you don't have to. If you do it this way, when you do Pythagorean's theorem, you're gonna see that it's a 45. But I just unrationalized it because that brings us back to the one we know and love. That brings us back to the 1 and the 1 radical 2. But you don't have to do that. You can do this there and you're still going to find out it's a 45-degree angle. The 45s are nice because the legs are the same. It's an isosceles right triangle. Okay. This guy, cosecant, if you don't like looking at the cosecant, take its reciprocal. Oops, negative. Take its reciprocal. Where is the y negative? Down here. So I'm looking at these two triangles. I say this has to start here and terminate here. That's my terminal side. This has to start here and terminate here. I set up my y over r. I see this is my special triangle because I memorized the death out of them. I say this is 30, so that goes into 180 6 times. 6 pi over 6, 12 pi over 6. 180 plus 30. And be careful of this one. If this is 360, you're coming all the way around. You're stopping 30 degrees short of 360. That's your 330. Or take those and just use the formula to convert them. How about if I say this? Isn't it what? Is my sine? My sines and my cosines are less than 1, except for when? On those quadrants. Think back to your unit circle. So, me, I would always start like this. And I'd say x, y, cosine, sine. How do I know that that's a quadrant angle? Because it's a 1 or a 0. A 1 or a 0 isn't going to make me a triangle, is it? No. And 1 is going to be the same as my radius, so that's not going to make me a triangle, right? Those are your high points and your low points and your zeros for your sines and your cosines. 0, 1, negative 1. So next week, when we start graphing these things, we're going to go graph them off your quadrant angle. So where I look for my y to be my negative 1, so it's not there, it's not there, it's not there, it's right there. So I'm at 3 pi over 2. How about if I say this? Sine of theta equals 0. It'd be 0, or this guy also has a 0, pi, or if I said from 0 to 2 pi, you could put 2 pi. Depending on how I say this, see where this inequality is? That's equal to 0. This is not equal to 2 pi. So in this case, I wouldn't put my 2 pi. See where that inequality goes? Yes.
I know you said like after that quiz that we took that we'd see that chart again. Is that something?
Well, that you have to know to get here. You know. Yeah, I'm not going to give you the chart to do, but I mean, you can do your own chart. What if I were you, when I get my test, the first thing I would do is put my 2 special triangles at the top of my page and put my quadrant angles at the top of my page, so that when you need to remember them, they're right there. Rather than when you're in a panic and say, where did I see that 1? Where was my 1? Where did that come from? You look at the top of your page and there's your quadrant angle and it's staring at you. Always do those things before you get into panic mode. And I noticed some of you guys do. I noticed on some of your tests I see information at the top. That's how I always took my test.
For number 15, how do you like 7 5 6 and 1?
How do I know? Because I count from where I rotate. So if I came up to here, because my bottom number is going to be a 6, this has to cancel out to pi. And this will be 6 over 6. This will be double, because this cancels out to 2 pi. So as I come around, remember, the only things I'm going to get is this little bow tie off of here. So 1 less than that would be 5 pi. I didn't hit 6 yet. One less, 1 more. Because if we did 2 for this, say for instance we did 2, we went up 230, isn't that a 60 degree? And then we would have used divide by 3. So you're only going to find 4 of each one. They're going to be a little bow tie. That was a good question.
Could you tell it was like over 6, like dividing 180 by 30?
Yep. That's it. Let's hit this next one. Are you guys okay with this? Give me 3 decimals. Put your mode back in degrees. Make sure your mode is degrees.
Wait, what was it?
Go ahead. Sorry. Everybody good with this? And that's your angle of reference. Always label, if you forget, always label your hypotenuse first. This is your angle of reference. Label your hypotenuse. There's only one hypotenuse. There's 2 legs. Then go opposite this angle. Go next to this angle. Adjacent means next to it, touching it. So what parts do I have or need? I have my adjacent, and I need to determine how wide is the river. That's this piece. That's your perpendicular line. Don't you measure things by the straightest point, right? There's always like some kind of altitude in there. Again, an escalator. Escalators are those things you take up at the mall like that. So here's your escalator. It goes up, it's 152 feet in length. It rises to a platform. So it comes up to the next level of your mall, let's say, right? And it has an angle of elevation of 30 degrees. So this is what I draw. I want to find the height of the platform. How high is it? Between floors. Think of like when you're in the mall. How high is it between floors?
So what is between
Feet. The one little thing is a foot.
2, like 2.
Foot. Yes.
What's the length between the bottom?
Yeah, that's what.
No, because the escalator itself is 152 feet in length. So that thing that you're riding on, like when you put a ladder along the house, your ladder is 10 feet long, right? Your escalator is 152 feet long. If you measured that distance of the escalator, that would be your hypotenuse. You know when they also say you put a 10-foot ladder against your house? That's your ladder, right? That's 10 feet.
You would say like
it would say 10 feet away from the house would be here. But a 10-foot ladder would be here. And the last one,
Oh, wow, no, I didn't know.
yes, come on, we did like 3 of these. Make sure you know this one.
Yeah, I put why I did 37,000 over or underneath X. I did the opposite.
Okay, so here's your triangle, guys. Look, you have 2 right triangles here and one here. They share this piece. They share that. So if I want to find the distance between, remember what we did yesterday? We're not using law of sines. We're using just trig functions. So this little guy has to be from here. So this is my 76. Isn't that smaller than that angle here? The closer you get, the steeper you have to look up. Think of looking at something when you're real close to look like almost straight up. There's my 76. Find this part. There's my 32. Find the big part. And then subtract them. You got to know this.
Which one do you subtract? Like you do.
Well, obviously you got to subtract it so it comes out positive. So you're going to subtract the big one, the one with the 32, minus the one with the 76. Don't go by your angle. Go by which part is longer over here. If you subtracted and you came out negative, then you subtract it backwards. You can't have a negative length, right? So subtract them. I would just.
Are you sure this is the wrong one there?
Am I sure? Yeah, I'm sure.
Yeah, I don't know why I switched that. Like I put the X over 37,000. I don't know why.